Welcome friends, I'm Miss Vickie from the Brighton District Library. Today I'm going to be showing you some fun experiments that you can do at home. Attached to this, the blog post is the list of all the experiments, what you need to do them with, and how to do them. So just in case you want to try these fun things at home. Today I'm going to be doing 2 experiments with balloons. Before we get started, I should just tell you about some of the things that scientists kind of recommend you do when you're doing something that you may have not done before. It's kind of nice to have something to cover up your clothes with in case things spatter, depending on your experiment. If you have long hair, it's kind of nice to pull it back out of the way instead of if you're using fire or some different chemicals together, you don't want your hair getting in them. And then for safety, safety glasses are really nice to protect your eyes in case anything bursts. So those are just fun things that maybe you should do if you're going to try some of these experiments. The most important thing is adult supervision and permission. Before you try any of these, you might want to make sure your parents are okay with doing them. The first thing we're going to do today is called the fireproof balloon. Now, if we have some balloons here and I have a candle and it's lit, so if I take one of the balloons and I hold this balloon over that candle, what do you think is going to happen? Can you guess? Let's see. If I just hold it over here like this, what's going to happen? It popped! Because the balloon, the heat from the balloon snapped it. And what else did it do? Can you tell? The burst of air that came out of the balloon put out the candle. So we need to light it again for me to show you the trick. Light the candle again. Now I'm going to take another balloon and do the same exact thing. Let's see if we get the same reaction. Take a balloon and hold it right over the candle. The candle's actually touching the balloon. Is it popping? No, it's not popping. And you're saying, what's happening? Let me show you. Right here. Get up close so you can see inside the balloon. Do you see inside the balloon? There's water. So before I blew it up, I put, maybe 3 ounces of water in there. And that's where I held it over the heat. Because the water, when you hold it over, the candle's hitting where that water is, because water is really great about soaking up heat. And the thin balloon lets the heat pass through and very quickly warms the water. Well, as the water gets warm, it rises and the colder water gets down and it's constantly exchanging, so the balloon never pops. It just keeps repeating. So the soot at the bottom, do you see the black? That's where the candle actually touched the balloon. The flame touched it and it's carbon at the bottom, so you can really prove that the candle touched the balloon and didn't pop. Exciting. Give it a try. The next one we're going to try is called the screaming balloon, but this one I need to put out. It's called the screaming balloon. This balloon makes a really screamy kind of sound. And you said, what is making that sound? Let me show you. We have some hex nuts. Hex means 6. Do you see? There's a bigger one and a smaller one. They recommend a 1/4 inch one, which is the littler one. It's very thin. This is a little bigger one, almost a 1/2 inch right there. And it's thicker. Now, the thicker the hex nut, the faster, the more heat's going to generate as it spins, and it will pop the balloon faster. So if you blow up your balloon a little too much, it will pop the balloon a lot faster. And when I did this at the library, all the kids had to, of course, do it until they popped their balloon. But so if you have a really thin balloon, it'll really pop it. I usually use the 1/4 inch ones so I can enjoy the screaming balloon a little longer. Let me show you. Take my balloon. I put my 1/4 inch nut, hex nut, inside. Then I blow it up. Now we can leave it like this. You can blow it a little farther. If you get it really big, the more you spin it, you'll probably pop your balloon. I'll tie off the end. There's the end. Now how to make it actually make the sound. The end where you tied it, if you hold it sort of like a bowling ball and just do a round really fast, and it'll kind of tumble for a while and then it'll start spinning. And what's really cool, once you get it going and stop, it still goes until it gets slower and slower and then stops. So you can do it this way. I've done it this way too. This way. And the more you spin, the faster it goes and generates heat. So there's two things going on in the screaming balloon. Two things. One is centrifugal force, and that is the inward force of that hex nut around and around on the inside. Just like in a carnival ride that you ride, you know, when it goes around so fast and you're pressed against. The faster it goes, the more you're pressed. Well, that's what's happening. You're spinning, and the hex nut's being pushed against the side of the balloons. But the hex nut is not smooth. It's got edges, 6 of them. And as those edges hit the outside of that balloon, that inside of the balloons goes around faster and faster and faster, that's what's making the screaming sound. So I hope you have some fun with these 2 balloon experiments, and we'll catch you at the next one. Bye. Good morning, friends. Back with another science experiment, one I've actually never tried, and it's called the rubber egg experiment. All you need for this one is a raw egg, some household white vinegar, and a clear glass to be able to see through it. So I'm going to turn you down so maybe we can see the table and some of the fun things we're going to do. So basically you just put the egg, be very careful putting the egg into the glass, cover it with vinegar. Now, I'm going to show you what's happening. Now, the eggshell is made up of calcium carbonate, and as you leave it in there, little bubbles start to form on the egg, and you'll watch them. You'll see little tiny bubbles coming up. That is the acid in the vinegar dissolving the calcium carbonate on the shell of an egg. So see, the bubbles are starting to form on that egg, and you leave it that way for 48 hours, 2 full days. And then let me show you what it looks like. After 2 days, look at all the bubbles, and on the top you'll see some brown stuff, and that's what is the calcium that it's eaten off the egg. And now I'm going to take it out of here, and let me show you some of the brown stuff, and we're going to wash it and see all that brown's going to come off. So let me push you down again. We'll see. I'm going to bring out, I'm going to show this. Bring it over here. We're going to take our egg out of here, and we're going, it feels really funny. And we're going to wash it in the water, and all of that, look at all of that brown is coming off from my egg was brown on the outside. So we're going to wash off all that brown. And there's sort of some white film on there. We're going to rub that all off gently. And it feels like a rubber ball. No joke. Let me show you. There we go. There we go. Let me get you so you can see it. There we go. And I'm washing off all of that white film, and what we're going to come up with, it actually looks and feels just like a rubber ball. Look at there. Now what we're going to try and do, now let me show it to you. Got it all cleaned off. See that? It's all cleaned off, and it feels like a rubber egg. And look at this. Let's see if we can get this to work. I think it actually bounces like a ball. Look at there. Bouncing. Bounces like a ball. feels and looks like it. See there? So try it, and then what I'd like to see what would happen. Let's bring you up here with me with our egg. There we go. Trying out this new gooseneck lamp. So we have this. Let's see what happens. Can we shine a leg? Now look what happens. You can actually almost see through it. Look at there. So test it with a magnifying glass or a flashlight. And even you can bounce it around on the table. Bouncing, bouncing on the table. So you can, and what's also you can do is you can color the vinegar with food coloring, like maybe you would do Easter eggs. So this might come out blue or red or orange. So if you put that in the vinegar, the color in the vinegar, it will also change the color of your bouncy ball. So now we have our own little bouncy ball. But what is also sort of interesting is there's still an egg inside of this. That is what is so amazing. So now if I take a knife, or if I just really try and break it really, really hard, dig my fingers in it, look what happens. It's still, there's a film of the egg from the outside, the rubbery egg, and what's inside is still the yolk. It's still the slimy yolk, just like it is, but we had it as a bouncing ball. So that is another fun experiment for you to try, and maybe you can color yours to be a different color. So happy rubber egg experiment. Hello everyone, Miss Vickie back for a few more science experiments for today to do with pumpkins since it's close to Halloween. We're going to try some of our fun things that we've done before, such as oobleck, and we're going to try it in a pumpkin. Now, oobleck is an important thing because it's learning about mixtures, about two or more substances coming together to form a new material that can then be separated again. Now, do you think oobleck can be separated? We're going to give that a little shot at the end, and I'll tell you how to do it. First, we have to actually get our two substances, which are cornstarch and water. And we're going to try mixing that in a pumpkin with maybe just a little bit of pumpkin guts to make it a little different. So let me show you down to where we have our cut the two, a pumpkin, got a half a pumpkin here. So we are already right there. Let me get it so where you can see it really good. Now, I'm going to take some of the cornstarch and put it right into the hole that I've carved out of the pumpkin. Put a little bit in there, just enough to fill your hole. You don't have to do the whole cup. However big your hole is of your pumpkin, you fill it in. And then we pour just a little bit of water, and we get our spoon, just a little bit we start with, and start mixing it. You're going to need more water. It's starting to get a little bit hard. As you mix the water in, you'll see it start to get thick and stick together. And making that oobleck. Needs a little bit more water. Just a little bit more. There we go. You see our pumpkin guts I took out of the pumpkin to make our hole in the pumpkin. Starting to form the oobleck. Now about this time, it's time to let go of the spoon and try it with your hand. So we're getting some of that little pumpkin mixture in there. And now, let's see what it feels like. We start to gather together. It starts to solidify, but as soon as I touch it, it gets to be a liquid. So if I leave it alone, it hardens. I'll leave it in here for just a minute by itself, and you'll be able to see how it's hardening on my fingers? Look, see, it's hardening. This is all hardening. Got to peel it off and then put it back into here. Peel it off the sides because it's hardening. Now, if it's too liquidy, we can put a little more cornstarch in it. Not a lot, just a little. This is a very messy thing, which is okay for Halloween. Now, see, you can pat it down. Now it's hard. You see it's hard? It's not soft anymore. It's very hard. I actually had some of the patrons that were in it, they actually walked on a pool of this. But if you pick it up like this, then it turns into a liquid. See how it's sliding off my fingers? It's turning into a liquid. Put a little more water. So if you leave it alone, it's very hard, very stiff. But then, if you pick it up, then it turns liquid in your hand. And that is Oobleck. So we should add a few more of our little pumpkin seeds. Got to add those in there. So as soon as you touch it, it gets a little bit of liquidy. And if you leave it alone, oops, starts to get really hard. See how it's hard on my fingers? I have to scrape it off. And it's hard. Now, if you were to leave this alone, you can pick it up and then it turns fluid in your hand and starts leaking right through it. So that is something really cool about Oobleck. Maybe add just a little bit more. There we go. Now it's really hard, but when we pick it up in our hand, it flows right through our fingers, except for our pumpkin guts. There's our pumpkin guts. There it is. Yeah, pumpkin guts. Now I also made one in a bowl earlier. I wanted to show you that. Seeing it right here is very hard. See, it doesn't fall out or anything. But if I pick it up, scrape some out of it, and it warms up in my hand and just starts to dry up. And that's, if you leave it alone, all of the water will evaporate eventually and it'll turn back into cornstarch. That's what makes it a mixture. So try some Oobleck in your pumpkin and see if you can make it hard and then pick it up and watch it become a liquid. Pretty cool. See you for the next one. This is Miss Vickie one more time just to tell you, never put Oobleck down your drain. You never put it there because it will clog it up. So any Oobleck you might take, you just scrape it out of a bowl if it's you want to keep and just throw it in the trash. Never put it down the drain. See you soon. Hello friends, Miss Vickie back again for our second pumpkin experiment. This one is one of my favorites of all time, slime. We're going to make pumpkin slime, and I'm going to show you, I've already cut the top off my pumpkin, and I've left some pumpkin guts in there to mix in with our slime. And the ingredients you need for this are some Elmer's clear glue. You need some water and the Stay Flow liquid starch. I also have some glitter because I always like to add the glitter into the slime if I can. So we get started by, the recipe says to take your glue, pour it in a bowl, and I will put it down so you can see hopefully what we are doing with our bowl. There it is. And let's see if I can make it a little bit easier for you to see. There you go. Now, what we're going to do is we're going to pour our glue into our bowl. Nice clear glue. We'll make sure we get it all out of there. We're going to add in our water. And it says to mix them good, so we're going to mix it. Okay, now I'm going to put in a little glitter. How about a little bit of silver? And a little bit of gold. And a little bit of the white snow looking one. It's one of my favorites. There we go. We'll mix that all up. There we go. Stir it up. Now we're going to put our liquid starch directly into the pumpkin. Here's our pumpkin. Here's our liquid starch. We're going to pour it directly into the pumpkin. And then we're going to pour the glue mixture right into the pumpkin as well. There we go. Now we can take a look and see inside the pumpkin. There we go. Look at there. We're going to stir. Now you can stir it with your spoon, but now as soon as it gets pretty good, then you need to stick your hand in and you need to pull out the slime. There we go. What do you think? Kneading it with your hand is the best. So you see our slime? So awesome. It's got pumpkin guts and seeds in it. What do you think? Isn't that awesome slime? If you put more liquid starch, then it becomes thicker. And they said a trick too is to take some of that and put a little bit on your hands before you put your hands in. Let's see if that works. I'm going to put a little bit on my hand. And rub it. Oh yeah. Then it doesn't stick to your hand as much. So if you put a little liquid starch, then we have marvelous pumpkin slime. Look at this. Yay! What you can do with this too is you can put it in a bag, a plastic bag, and make it sort of like a sensory bag. Isn't that wonderful? Nice slime. You can try it with just the glue and the liquid starch too to see if that makes any difference. But there you have it. Instant pumpkin slime. See the pumpkin guts in there? Yeah. So have fun with this one on Halloween. Bye. Now that we've made our cool pumpkin slime, we kind of need to know why science works to make it the way it did. Well, I just want to let you know that the glue is a polymer and its ions are in a chain, in a long chains. And it keeps moving and it just keeps those strands separate. But when you add the liquid starch says, hey, get together. You know, when they start mixing together into a thicker slime, all of them start to blend together in chains and all together. And that's sort of like spaghetti, you know, after a day, you know how the spaghetti all kind of sticks together? Well, that's the same kind of thing. It's called cross-linking. So they're actually crossing over each other and binding together to make it slime. Now you wonder is slime a liquid or a solid? Like Oobleck, they're a bit of both. It's both a little bit solid and a little bit fluid. So that's called a non-Newtonian fluid because at times it is a solid and sometimes it's a liquid. So that's a cool thing to know, a non-Newtonian liquid. Hi, back again, my friends, for the last of our pumpkin videos. And this one is kind of exciting. It's the baking soda and vinegar reaction, which I'm sure you've tried before. I've just never done it in a pumpkin. So I carved my pumpkin. Here it is right there. There's our pumpkin all carved. Now, what the instructions say to do is to put a little baking soda inside. So I used a little funnel. And I poured a little baking soda. Now I probably poured a lot in there. And then I shake it up. Shake it up a little bit. And it says, oh, well, you can, losing a tooth. Then you can put some glitter in, or you can put some dish soap. Dish soap will make it some bubbles. Losing my tooth. That's okay. So we're going to put a little glitter in. Of course, some gold glitter. There we go. And a little dish soap, because that makes it bubble a little faster. Make some great bubbles. There we go. Then we're going to add some food coloring, because we want to kind of make it some icky color green to go with our orange pumpkin. What do you think? Let's put some green in there. And then I have some neon colored. Ooh, let's see what color that makes. Let's see if I can find my, there it is. Now we've got some baking soda in there. We've got some dish soap in there. Now we're going to add some vinegar. Now it says to take like a baster and just put a little in at a time. I'm all for going for let her rip. So we're going to put some in here. Let's see if I can get the lid back on really fast. Okay, we ready? Let's pour the vinegar in. Here it comes. Let's pour some more. There it goes. Isn't that cool? Whoop, it's going to overflow my little tray. So have some fun with the baking soda and vinegar in a carved pumpkin. Make it throw up all over your table. Have some fun. Bye. Hello, my friends, one more time. Miss Vickie had some ideas because I think I had the mouth too big on the first pumpkin, so it all came out through his mouth. So I carved another one where it's smaller. Let me show you. There we go. Now we're going to try the same thing. So I put some, let's see, I put some baking soda and some dish soap and some glitter and food coloring in this one as well. And we're going to see, but this one I think still has some life in it. Let's try this one again. Still coming out like crazy, but all through the mouth because it's too big. Let's give this one a shot. See what happens. Can you see its little mouth there? Yeah, let's see if it comes out. Let's see what happens. Oh, it comes out everywhere. Look at there. Yes, there you go. There you go. If you put a little more baking soda, and it comes out. A little more baking soda, a little more vinegar. And it comes out everywhere. So when you're carving your pumpkin, think about what you want it, where you want it to come out at. All right? And I just thought I'd show you what I also made from a lot of the pumpkin guts. You can make a sensory bag of all the pumpkin guts. And then you can seal the top with some clear tape, packing tape. And now you've got a nice squishy bag. You can put a little jack-o'-lantern face on the front, and it's all your slime and pumpkin guts in there. Thought I'd share that with you. Have fun. Good morning, everyone. This is Miss Vickie again for another wonderful little science experiment from Steve Spangler called Ghost Eggs. Now I'm going to show you where the ghost eggs are hiding. Let's see if you can find them. Do a switcheroo so you can take. Down here, do you see any ghost eggs? Nothing's there. Let's go down to the side. See if you can see any in there. Do you see any ghost eggs? I don't see anything. What we're going to do is we're going to make them appear with our vampire blood. Let's drop a few little drops of vampire blood into our mixture. What happens? There's the vampire blood going down in there. And I'm just going to see what happens. Do you see any? Let's see what happens. Do you see any of the ghost eggs? Well, it's coloring the water. I see it all going down and mixing up. No, I don't see anything yet. Let's do a little stirring. You see anything? Well, the vampire blood makes things glow, but we need a special light on it. Yes, so let me get a special light, see if we can see any ghost eggs that way. Let's turn on our special black light. Let's see what we see. Oh, what do you see? Do you see some ghost eggs in there? Yep. The special vampire blood is making them glow enough under the black light so we can see them in there. You want to see all the way around? You see the ghost eggs in there? Let me lift out a few, see if you can see them. I'll hold it up here so you can see. Oh, no. There we go. We lift a few up. You see them? There they are. There they are. Do you see them? There's our ghost eggs. Put them back in there. Can you? Then we'll go down in here. There we go. There's our ghost eggs. Yeah. Now if we turn off the black light, what happens? Do you see them anymore? I don't see them. They're all gone. Look at that. Is that amazing? And now you want to know, let me show you what they actually look like when we start. These are little jellies that are used to support plants when you put them in a jar. And this is how they start. The little eggs start out teeny weeny. And then you put them in a jar full of distilled water for about 24 hours. And they grow. They grow huge to be like this. But when you drop one in the water, when you drop it in the water, it disappears. The light is refracting off the curve of the egg, the clear egg, and you don't see it at all until you put the special magic vampire blood, and it's actually just a UV solution that when you turn on a black light, you can actually see them in there. There they are. And what's happening? Well, basically, the ghost eggs are made up of two different polymers, hydrophilic and the super absorbent polymer, and the hydrophobic, the water-avoiding polymer. And they start out as these teeny-weeny little balls, but when you put them in water, they absorb 300 times their weight, so that they are basically almost 99% water. They're just little round balls. Very fun to play with. And if you look closely, you can barely see the light passing through the water. It's refracted off of the curve of those balls, those jelly balls. And the bright UV light is what makes them glow. It makes objects glow so you can actually see them under the water. Isn't that a fun thing? So if you get some of these jellies, you can get them at Joann's or at Michael's in the flower department, and they become these jelly balls. And you can get them in different colors. You can get them in blue and red and yellow and green to make a fun pile of ghost balls. But if you put them in clear water, the clear balls will disappear. So I hope you have a little fun. Hello, Miss Vickie back with another fun experiment called glow-in-the-dark slime string. And this is another Steve Spangler wonderful fun experiment. And first I put some water in my bowl. I added some activator solution, and this, it comes from Steve Spangler. It's actually calcium carbonate, so that when we squirt our string slime in there, it's going to immediately turn into slime. So if I just drop a little here in a big slime string, let's see what happens. It immediately turns into string slime. Look at that. And see, look at that. It's got water-filled bubbles. You see that? Inside is actually bubbles. Let's see if I can get one of those to break it so you can see it. Look at this right here. And we're going to break it. And there's water inside of there. Oh, it just water everywhere and glue. Let's see the string slime. Now, right now, it just looks like yellow. But what if I turn on our black light and there it glows? Look at the big bubbles. We can do little drops for like maybe some eggs. We could do little drops here and there. And look, they become little bubbles everywhere. And I can string some more in there. There it is. Glow in the dark slime. Look at that. Isn't that fun? Look at that. Oh, and there's a big one. Look at that. There's a bulb hanging at the end of it. Look at that. Filled with water. There's actually water inside these little strings. And if you would take it out and lay it like on your tray and leave it overnight, that would just sort of dry up because all the water will evaporate. Isn't that awesome? Now, basically what's happening is this sodium alginate, the string slime goo, it changes to a solid the moment it touches the water with the activator solution in it, which contains calcium. And that is another cross-linking we talked about earlier, where the two come together and pull everything, make them stick together. And it's cross-linked polymer, every strand. And then the fluorescence is a type of luminescence that occurs with some form of radiation, such as the UV light, and causes the object to glow. Isn't that amazing? Now, what's kind of fun is the chemical called calcium carbonate. One of the main ingredients in it is pickle juice. So you're thinking what I'm thinking? I think if you took some pickle juice into a cup and squirt some of our activator into it, you'd make slime just like I did. Don't eat it though. But you can get this from Steve Spangler, and it turns into wonderful, slimy, glow-in-the-dark strands. Isn't that fun? I hope you enjoyed it. And I just want to let you know, some of the glow-in-the-dark slime like we made in our pumpkin slime, well, instead of the clear glue that I used, if you bought the glow-in-the-dark glue, which you can from Elmer's, it would glow in the dark just like this does, except it'd be like the slime like we did in the pumpkin slime. So I hope you have some fun. Thanks for watching. Hello again, my friends. This is Miss Vickie with our last little fun science experiment, fun thing to do for Halloween. This time I used the glow powder from Steve Spangler. And all you have to do is cut a nice pumpkin face out of contact paper and press it down really hard on your pumpkin. Then spray it with spray adhesive, and then sprinkle your glow powder on, and you have a wonderful glow-in-the-dark pumpkin. It glows even better under your black light. The glow-in-the-dark powder can be used for a lot of fun things, and I'll show you. You can write your name. You can do it with glue and sprinkle the powder on. If you have it on a piece of construction paper or cardstock, and then you can have it glow your name in glow-in-the-dark letters in your room. And this is just to review all the fun glow things we did with Steve Spangler's fun. We did our glow-in-the-dark ghost eggs. We did wonderful slime. The longer you leave it in there, the harder it gets, and you have big things, bubbles are all in there. They get harder and harder, but still filled with water. So that's another fun thing. And then you can use the glow powder for many, many fun experiments as well. So I wanted to say Happy Halloween from the Brighton District Library. Bye.